A sample of serum of mass 30 grams is cooled from 270 Kelvin to 230 Kelvin at constant pressure by the extraction of 1.1 kilojoules of energy as heat. What is the heat capacity of the sample? So to answer this problem, we will use the formula Q is equal to mc delta T. So Q stands for heat, and in this problem it says here that 1.1 kilojoules of energy as heat was extracted. So extracted means heat was released to the surroundings. So your Q must be negative 1.1 kilojoules. So why negative? Because the process is exothermic, and for exothermic process, Q is negative. So negative 1.1 kilojoules, and that's equal to M. M is the mass, and the problem it says here 30 grams. C is the specific heat capacity, which is unknown in the problem. It's not given. We're looking for it. So just write C. And delta T is the change in temperature. So when we say change in temperature, that's your final temperature minus your initial temperature. So in the problem, our final temperature is 230 Kelvin and our initial temperature is 270 Kelvin. So final minus initial, 230 minus 270, this will give us negative 40 Kelvin. So if you want to solve for C, or the specific heat capacity, all you need to do is to divide both sides of the equation by 30 grams times negative 40 Kelvin. So you do that on the right side, you also do that on the left side. So 30 grams times negative 40 Kelvin. So the 30 grams would cancel out on the right side. The negative 40 Kelvin also cancels out. So what's left on the right side is C. And on the left side, you need to solve this using your calculator. So that's negative 1.1 divided by 30 times negative 40. And you will get approximately 9.17 times 10 to the negative 4. And the units would be kilojoules on top per gram Kelvin. So I repeat, the units would be kilojoules per gram Kelvin. Or if you want to convert it into joules per gram Kelvin, all you need to do is to multiply it by 1,000. So if you multiply your answer by 1,000, you will get 0.917, and then the units would become joule per gram Kelvin. So either of these two is the answer. It depends on what unit you want your answer to be.